All right, friends and neighbors, welcome back to another networking video. I'm going to jump right into a demo today. We are going to do a little bit about OSPF in the next couple of videos, and I know I was doing a VoIP journey. We'll come back to that, but we got some other things to cover first. So what we've got in front of us is two identical configurations. So on this side, though, I'm going to do the routing information protocol. Whoa. Or RIP, and this is sort of our training wheels protocol, and here we're going to do open shortest path path first, or OSPF. Now I'm just going to do some configuration differences here, but I suppose it's worth mentioning a couple of other things. Both are what we call interior routing protocols. And so that means they're not designed to be run on the internet, although they do have some differences in where you might deploy them. And I might say that RIP really isn't deployed very much at all these days. I would be very surprised if you came across it, although I'm sure there's a couple of pockets out there. RIP is also what we call a distance vector protocol. It only cares really about getting to a network that is that way and that far away. It doesn't really care very much about conditions of the network, speeds, or anything like that. OSPF is what we call a link state protocol, and we'll see that there's more to the metrics associated with OSPF than RIP, and so for many reasons OSPF is considered a superior routing protocol to RIP. Now, another thing that's worth mentioning is that RIP has an admin distance of 120. And if you remember from the previous videos, I'll link them in the description, when you are comparing routes, the first thing that you look at is prefix length, which is how long the mask is, and with the idea that short masks are farther away from the destination or encompass a larger address space, and the longer the prefix length, the closer you are to the destination. The next stop is the admin distance, and so RIP has an admin distance of 120 and OSPF has an admin distance of 110. So the lower the admin distance, generally speaking, the better the route is. So directly connected is the best, static is the next best, and then you go into your admin distances. Alright, now the metric here in a RIP topology is hop count, which just means how many routers are you going to pass through, and then the metric here in OSPF is a non-dimensional, which means that it can take up, there's no units that you can apply to the metric because there's a couple of factors that we're taking into account. Alright, so we're going to do the exact same topology on the two sides. So maybe we'll make this 192.168.1.1 over here. We use /24s everywhere just to make life easy. We'll make this 3.1, and we'll do the exact same thing over here. 192.168.1.1 and 192.168.3.1. And that makes this in the middle the 2net. Alright, now previously you've seen me do topologies like this where it's a small simple topology. There's no reason to do a routing protocol, so we would simply do static routes, but that's not what we're talking about today. So let's do the hosts first. Auto-complete that. We're not going to worry about a host in the middle. And our gateway on this side. Even though it's going back the other way, we'll just continue to use 254. There we go. We'll do the same thing over here while we're thinking about it. 254. Boy, I'm having a little trouble typing today. And 192.168.3.1. .254. All right, on to the routers. Now, just getting a routing protocol up and running is actually really straightforward. It's not difficult at all. And so we're going to find out that getting OSPF up and running, even though it's considered a more complex protocol, it's a better protocol, is about the same amount of work. Just a couple of keywords and tricky phrases that are different. So we're on router 0 here, so we'll go to intf 0 / well, first we'll do config t, and we'll see IP address 192.168.254, and then our mask. Do a no shut. We'll see that interface light up, and we'll do 2.253 on this side, and then over here we'll do, this will be the 254 side. .254, our mask. No shut, that'll bring up the middle interface. There we go. And this will be 3. And we'll do a no shut here. Alright, now we're going to see if we can get away with something here in Packet Tracer. We're going to do a show run. And I'm going to take the things that I've configured here, and we're going to copy them. And we're going to go right over here to this router. Now this works on an actual router as well, a real life router. If you just go to the config prompt, and we can paste those commands right in there. What we might have to do is the no shuts a lot of times don't come across. So let's go to intf 0 / 0. We'll do a no shut here too. Now we're going to do the same thing on the other router. Now it's not as big a deal with this small topology, you know, but if I had a larger topology, more complex, and I just didn't want to do it again, same thing works. But remember that you got to be at the config prompt. We'll do that, and we'll do no shut. Now in this topology, I could probably almost have done the same speed if I had just manually typed it all in. Okay, now on to the RIP part of this. Alright, so if we take a look at our routing tables, we know that both of our networks will appear as directly connected routes. And the problem, of course, is that router 0 knows about the 2 directly connected, and the same with all the other routers. But they don't know about the one that's on the other side of the router. So if I was doing a static routing command, I would do something like this. I would say IP route, and then where do I want to go? Well, I want to get to the 3net, and then here's the mask that I think goes there, and then who would I send this to? Be 2.254 here. But that's not what I want to do. I want to use a routing protocol. And again, this is a simple topology. You would never really use a routing protocol on something of this size, but we're just doing it for a demo. So what we're going to do here is we're going to say router RIP. Alright. Well, we can see that the prompt changed. What do I have available to me? Well, there's not a whole lot here. I do want to do version 2, and that's useful because it does the subnet masking. If you were, I doubt you'd run into a RIP topology, but if you did run into a RIP topology, you can be sure that it would be version 2 and not version 1. Well, now let's do this. We're going to advertise the networks that we know about. So there's only really 2 in this case that I know about, and that would be the 1.0 network and the 2 network. And that's it. Now you could argue that since both of these routers already know about the 2 network, that there's no reason for me to advertise it. And that would be true. But we don't really know what the topology would be. And so what a router would typically do is advertise all of its directly connected routes. All right. Well, now there's still nothing happening here. I haven't learned anything yet because the other router is not ripping with me. So you see I still got my directly connected routes. If I was going to do the simulation, though, well, let's actually do this. Let's edit our filters. We'll get rid of some of the stuff that we don't want to watch right now. There you go. There's a pro tip for packet tracer simulations. Okay, so now we can see that router 0 is spitting out RIP messages. Okay, but of course to no avail at this point. Well, let's get this router going, and we'll do router RIP again. And this router will advertise the routes that it is directly connected to. In this case, the 2 and the 3. So I'm going to say network 2.0 and 3.0. So pretty straightforward. And if we were to peek at our simulation again, we would see RIP messages coming out of router 0, and then RIP messages are now coming out of router 1. So huzzah, yay. What did that buy us, though? Well, it taught us where the other network is. And here we have our RIP learned route. Now, it's instructive, I suppose, to take a look at this routing table entry. And we can see, first of all, we got this nice little R out here. It just tells us that it's RIP, and we get that from up here on a Cisco router. And then here's the network and the mask, but what's this about? Well, that is the administrative distance and the metric. So 120 for RIP, and the metric is 1 because this network, actually this is the 1 network. So this network is right over here. It's just on the other side of this router from the perspective of router 1. So it's on the other side of router 0, so 1 hop away. And then of course we've got, well, who told us about this? Well, if you remember my numbering convention, I think I made this interface 253 and this one 254. And the same thing should be true over here. There we are. And that's it. We have now learned the entirety of the topology, and so theoretically I should be able to ping all the way across. Now the first one will time out, right, because we've got to wait for the ARP tables to update. There we go. Success. All right. Well, let's try this on OSPF.